Hello everyone. So in this video, I will show you an example of a compressible flow in a converging nozzle. So in this question, there's a large tank that is filled with nitrogen, and the nitrogen has this isentropic constant, or also called as specific heat ratio. So basically K is 1.4. So K is basically the Cp over Cv. And then we also have another, um, the one here is gas constant for nitrogen, right? So the tank is connected to a converging nozzle as shown in the figure. So the pressure and temperature in the large tank are 200 kilopascal absolute and 450 Kelvin. So this will be your stagnation, pressure, and temperature. All right. Then the nitrogen flows isentropically through the converging nozzle to a back pressure of TB 165 kilopascal absolute. So the P back, the back pressure is 165 kilopascal absolute. So you need to determine, what do you need to determine? The Mach number, the temperature, and the velocity at the exit of the nozzle. So if you write it in the symbol for Mach number is MA, so Mach number at the exit. So if I put this as the entrance, this is the inlet of the nozzle, so I put this as 0.1 and I put 0.2 at the exit. So you need to find Mach number at 2 and then temperature at 2 and velocity at 2. Alright, so Mach number, if you look at the the equations, the equations provided. So these are the equations that you can use to find the parameters or the properties. So Mach number, we have a few equations that have Mach number in it. However, so we need to know what are the given information. So since we only have P naught and T naught, we also have PB here. So we can actually check. The first thing that we need to do is to check whether there's choking or not at the throat, the throat of the nozzle. All right, the throat, at the throat of the nozzle. So how do you check choking or not? You need to calculate the P star. So you need to calculate the P star, the critical pressure. So how do you get critical pressure? You go back to the equation. So we have one equation here where we have P star in it, and we can rearrange so that you get P star. So P naught over P star, the equation is P naught over P star is equal to, you go back to the equation, you can see that P naught over P star is K plus 1 divided by 2. Then it's a power of K divided by K minus 1. So you rearrange the equation so that you get, therefore, P star is K naught divided by K plus 1 divided by 2, power of K divided by K minus 1. So I substitute the value. P naught is 200. Remember, it's kilo. So in Pascal is 200,000. Divided by K. K is 1.4. Divided by 2. So power of 1.4 divided by 1.4 minus 1. So please calculate If you calculate, you get 1056.5. Okay. All right. So 105 656.34 Pascal. So this value, if you compare with the P back, so the P back is 165,000 Pascal, is more than or larger than P star, which is 105,656.34. So if PB is larger than P star, that means there is no choking at the exit or at the throat of the nozzle, where in this case is the exit. So since no choking, your P2 will be the same as PB, which is 165,000 Pascal. So now you have P2. So if you look at the equation, if you have P2, you have P naught, you can basically get this MA2. So I will use this equation to get my Mach number at 2. Alright, so you write the equation. P naught over P2 equals to, look again at the equation, it's 1 plus P minus 1 divided by 2 times with Mach number 2 squared, power of K divided by K minus 1. Therefore, you rearrange this equation, you get P2 equals to P naught, you divide by everything on the right side. So 1 plus K minus 1 divided by 2, Mach number 2 squared. Then power of K divided by K minus 1. So P naught is 200,000 Pascal. Then you divide by 1 plus 1.4 minus 1 divided by 2 times the Mach number that you get. Oh, sorry. I think I got it wrong here because we already have P2, right? So we want Mach number. Sorry. You rearrange the equation. So, Mach number is P naught over P2. Then you want to cancel the power of K divided by K minus 1 on the right side. So here, K minus 1 divided by K. So K minus 1 divided by K. Then you minus with 1. Alright, you minus with 1. And before that, let me change this bracket to this. Then I change everything here to another bracket. Then these 2 times you bring up, and this K minus 1 you bring it down. And remember that the Mach number is power of 2. So here you have to put the cert. So you substitute the value 200 kilopascal divided by P2, which is 165,000, because there's no choking there. So 1.4 minus 1 divided by 1.4. Alright. Then you minus with 1. And then 2 divided by 1.4 minus 1. Then you have to put the cert here. Okay, so what do you get? Please calculate. So you will get 0.532, where this is a subsonic. flow. All right. So you answer the first question, Mach number at 2. Then you need to find T2. So you go back to the equation. We want T2. We already have Mach number at 2. So we can actually use this equation. So write the equation. T naught divided by T2 equals to, go back to the equation. Yeah. T naught over T2 is 1 plus K minus 1 divided by 2. So 1 plus K minus 1 divided by 2 times with Mach number and square. Alright. So rearrange. We want T2. So T naught divided by everything on the right side there. Then you substitute the value. So you will be able to get T2. So T naught, if you go back to the question, the value is 450. Sorry, not 400, it's 450. Then you divide with 1 plus 1.4 minus 1 divided by 2 times Mach number that you get is 0.532. Then square it. Alright? Then you square it. Then what do you get there? The value for T2 is 425.89 Kelvin. So this answer question 2. And then question 3 asks you to find V2. So basically, if you go back to the equation, since you already have Mach number, you already have temperature, you should be able to get V2. So we just rearrange the equation. So Mach number 2 is V2, set KRT. Therefore, V2 is Mach number 2 times with KRT2. So Mach number is 0.532 times with K is 1.4. So R, be careful. The R that is given in the equation is in kilojoule per kilogram Kelvin. So you have to write in, you have to times with 10 power of 3. So 0.2968 is basically kilojoule is per kilogram Kelvin is basically 296.8 joule per kilogram Kelvin. So it times with T5. T2, sorry, it's not the T naught, it's T2, where you get just now for 25.89. Then only you can get V2, which is 223.8. So that is all for this question. But if you have more, if the question asks you for more other parameters, then you can just look at the equation, then write down what all the information that you have or which are given or which have been calculated, then only you can manage to get other parameters. For example, if you need to find m dot, if you already have this, and if A is given, then you can manage to get m dot. Alright, that's it for this question. I hope you can understand. If you have any question, you can put it in the comment below. Thank you.